What if I told you our entire universe might be just a tiny speck inside a black hole, and that every black hole in our own cosmos could be a gateway to a brand new universe? Stick around, because we're about to dive deep into one of the most mind-bending ideas in all of science. Don't forget to hit that subscribe button and ring the bell so you never miss an exploration into the unknown. All right, let's get our cosmic bearings first. We all know the basics of black holes, right? They're these super-dense objects with gravity so strong that nothing, not even light, can escape once it crosses the event horizon. They form when massive stars die and collapse in on themselves. We think of them as cosmic vacuum cleaners, endlessly consuming matter. But what if that's only half the story? What if instead of just being endpoints, they're also beginnings? This incredible idea is called cosmological natural selection, or the fecund universes theory, and it was proposed by the physicist Lee Smolin. To understand it, we need to connect two of the biggest ideas in physics: Einstein's theory of general relativity, which describes gravity and the large-scale universe, and quantum mechanics, which governs the bizarre world of tiny particles. General relativity tells us that at the center of a black hole lies a singularia, point of infinite density and zero volume, where the laws of physics as we know them break down completely. It's a mathematical dead end. But many physicists believe that a true physical singularity can't actually exist. They think that when you get down to that incredibly dense, hot center, quantum effects must take over and prevent a complete collapse into nothingness. So, what happens instead? One fascinating possibility is something called a bounce. Instead of collapsing to an infinite point, the matter gets squeezed to an unbelievable density and then rebounds in a massive explosion. Sound familiar? It should. This bounce inside a black hole could be a big bang, creating a whole new universe. Imagine it like this. Matter from our universe falls into a black hole. It gets crushed down at the singularity, but instead of vanishing, it triggers a bounce, birthing a new baby universe. This new universe would be causally disconnected from ours. We could never see it or interact with it. From our perspective, the matter just seems to disappear into the black hole. But from the inside, a whole new cosmos, with its own space, time, and potentially its own physical laws, would spring into existence. This leads to a truly wild concept, a cosmic family tree. Our universe may have been born from a black hole in a parent universe. And the black holes in our universe, they might be creating countless child universes of their own. It's an endless cycle of cosmic birth, a multiverse of universes nested within each other like Russian dolls. Now, this is where Lee Smolin's idea of cosmological natural selection comes in. It's like Darwin's theory of evolution, but for universes. The theory suggests that every time a baby universe is born from a black hole, its fundamental physical constants, things like the strength of gravity, the charge of an electron, the speed of light, might be slightly different from its parents. It's like a tiny genetic mutation. Think about our own universe. The physical constants we have are incredibly fine-tuned for life and complexity. If gravity were just a little bit stronger, the universe would have collapsed back on itself moments after the Big Bang. If it were a bit weaker, stars and galaxies would never have formed. It's a cosmic Goldilocks situation. Everything is just right. Why cosmological natural selection offers an answer. Universes that have constants, which allow for the creation of lots of black holes, will have more offspring. If a universe has laws that prevent stars from forming, it won't make any black holes, and its genetic line will die out. But a universe like ours, which is prolific at making massive stars that then collapse into black holes, will create many new universes. Over countless generations of universes, a kind of natural selection would take place. The universes that are best at reproducing, meaning best at making black holes, will become the most common. And what kind of universe is good at making black holes? A universe with stars, galaxies, and complex structures. A universe like ours. So, according to this theory, our universe isn't fine-tuned for us, for life. It's fine-tuned to maximize the production of black holes. The fact that this same fine-tuning also allows for life to exist is just a happy side effect. We are, in a sense, a byproduct of a cosmos that is optimized for reproduction. This theory is elegant because it tries to answer two of the biggest questions in cosmology. What happens inside a black hole, and why are the physical laws of our universe so perfectly suited for complexity? It wraps them both up in one neat evolutionary package. But let's be clear, this is still a highly speculative idea. It lives on the very edge of theoretical physics. The biggest challenge is that it's incredibly difficult, if not impossible, to test. By definition, we can't observe these other universes. We can't peek inside a black hole to see if a new Big Bang is happening. So, how could we ever know if it's true? Well, physicists are looking for indirect evidence. One way is through something called the imprints of a pre-Big Bang era. If our universe was born from a bounce, there might be faint signals left over from the parent universe, hidden in the cosmic microwave background radiation, the afterglow of our own Big Bang. Scientists are meticulously scanning this radiation for anomalies that don't fit the standard Big Bang model. Finding such an anomaly wouldn't be definitive proof, but it would be a huge piece of supporting evidence. Another avenue of research is through developing a complete theory of quantum gravity. This is the holy grail of modern physics, a single theory that unites general relativity and quantum mechanics. If and when we have such a theory, we could use its equations to model what really happens at the center of a black hole. The equations themselves could tell us if a bounce is possible or if something else entirely occurs. Projects like string theory and loop quantum gravity are our best attempts so far at building this ultimate theory. Loop quantum gravity, in particular, is a framework where the idea of a big bounce instead of a Big Bang singularity naturally emerges. Let's also consider some alternative ideas. Not everyone is on board with the baby universes theory. Another popular concept is the information paradox. When something falls into a black hole, is the information about it destroyed forever? Quantum mechanics says information can never be destroyed, but relativity suggests it can be. This paradox has puzzled physicists for decades. One proposed solution is that the information isn't destroyed, but is somehow encoded on the surface of the event horizon, like a cosmic hologram, and is slowly released back into our universe as the black hole evaporates over trillions of years through a process called Hawking radiation. In this view, a black hole is more of a cosmic information scrambler and storage device than a gateway to another reality. Another idea is that at the center of a black hole, you don't find a singularity or a new universe, but something even stranger, like a wormhole, a theoretical tunnel through space-time that could connect to another point in our own universe or even another time. However, most models suggest these wormholes would be incredibly unstable and would collapse the instant anything tried to pass through them. So, we have these competing, mind-boggling ideas. On one hand, the fecund universes theory presents a grand evolutionary picture of the cosmos. It paints black holes not as destroyers, but as creators, engines of cosmic renewal. On the other hand, we have ideas focused on information preservation and space-time tunnels, keeping everything contained within our single universe. What's the takeaway here? The truth is, we don't know what lies at the heart of a black hole. It remains one of the greatest mysteries in all of science. But the fact that we can even formulate these kinds of questions and theories is a testament to how far we've come in our understanding of the cosmos. We are using the laws of physics, discovered right here on Earth, to speculate about the birth of entire universes. The idea that our universe could be one of many, born from a black hole and giving birth to others, is both humbling and exhilarating. It would mean that the cosmos is infinitely more vast and more creative than we ever imagined. It reframes our entire existence within a potentially infinite cosmic lineage. Are we the product of cosmic evolution? Are black holes the seeds of new realities? We may not have the final answer today, or even in our lifetimes, but the quest to find it is what drives science forward. It pushes us to build better telescopes, develop more powerful theories, and dream bigger dreams. Every new discovery about black holes, every gravitational wave we detect, brings us one tiny step closer to peeling back the veil on this ultimate cosmic secret. What do you think? Is our universe inside a black hole? Are new universes popping into existence all the time? Let me know your thoughts down in the comments. I'd love to hear what you think about this mind-bending topic. Thanks so much for joining me on this journey to the edge of reality. If you enjoyed this cosmic exploration, please give this video a thumbs up. And if you haven't already, hit that subscribe button and ring the notification bell so you can join us on our next adventure. Thanks for watching, and keep looking up.